here we're going to use the symmetry of the unit circle to extend our knowledge of the trig functions to a wider range of angles. We're going to use the table of cosines, sines, and tangents that we've already derived from the special triangles. We'll use this table and the symmetry of the unit circle to get the sine, cosine, and tangent of a wider range of angles. So let's look at an example. Let's try to use the symmetry of the unit circle to find the sine, cosine, and tangent of 5 pi over 6. Well, we know from the definition that sine, cosine, and sine, the x and y coordinates of where the terminal side of this angle meets the unit circle. This angle is 5 pi over 6, so its terminal side is in the second quadrant. And it's just pi over 6 radians short of a straight angle. Now what I'm going to do is reflect this terminal ray in the y-axis, and that gives me a ray that cuts the unit circle in the first quadrant. And the angle that that ray makes with the positive x-axis is pi over 6. And I know the coordinates of where that ray cuts the unit circle because they are cosine and sine of pi over 6, and they are the square root of 3 over 2 and 1/2. Now this point is the reflection in the y-axis of the point that I'm interested in, which is where the terminal ray of 5 pi over 6 cuts the unit circle. And when I reflect a point in the y-axis, what happens is that the x value changes to its negative, and the y value remains the same. Now that gives me the coordinates I'm looking for. That tells me cosine of 5 pi over 6 is negative root 3 over 2. Sine 5 pi over 6 is 1/2. And tangent of 5 pi over 6 is sine over cosine. That's 1/2 over negative root 3 over 2. And that's negative 1 over root 3. You should try to use this technique to derive the sine, cosine, and tangent of the other angles, and then look at the next video to see if you have the correct solutions.